Okay, it looks like my setup is working now, so I'm going to start discussing about sedimentary rocks. We are going to look at sedimentary rocks from two main perspectives really in this lab. So I have a few specimens here for sort of to kick off this chat about the different things that are characteristics really of sedimentary rocks, but two things comes to my mind. The first one is the grain size. So a key aspect of sedimentary rock, you have seen that probably through the lectures, is really to understand the concept of transport and essentially how it does influence the characteristics of class that form sedimentary rocks. And this class will have different dimensions as well as different nature and origins, depending really on the sedimentary environment where these rocks tend to lithify and form. The other aspect, if we sort of forget about grain size, relates to the composition of the carbonatic rocks versus silicic rocks versus other compositions. So there is, in essence, a variety of compositions of the primary constituent of the sedimentary rock, which again is a strictly function of the environment of formation of the rock, and this is affecting in turn the source, so the source materials. For example, we could make a quick example if we think at glaciers, so glacial processes, depending on where the glacier is acting. So if it's acting on a metamorphic assemblage, for example, so let's say we have the Himalayas with the abundance of metamorphic rocks, and let's say that these metamorphic rocks are dominated by metapelites. Well, the result of weathering and the action of ice will tend to form rocks that are dominated by a silicic-clastic component, which is part of these metapelites. So we will obtain rocks that are rich in quartz, rich in clays, and these are usually manifested in rocks that are essentially relatively fine grain and have a composition again that is dominated by quartz and silica. These are good examples are siltstones and sandstones. We are going to discuss specific specimens of this nature today. So remember, composition and grain size really dominate. So in the first part really of this lab, we are going to focus on the grain size, and then we will move into an analysis of these specimens to understand their compositional variation. And this ultimately will terminate with a discussion about the classification and nomenclature of sedimentary rocks. So let's start to work on these specimens and make some initial basic observations. And the first thing I would do is to look really at the concept of class. So if we capture here a specimen that is representative of a sedimentary rock, we can start to make some descriptions of this specimen. So I grab again my pen to illustrate some of the things I can see, and often it's useful to have also some water so that we can wet the sample and we can see better some of the features really of interest. So let's try to see if it does fit. I can actually wet this really well, and we are lucky because this specimen has been polished, so you can see a cut here, and otherwise, you know, this surface usually looks much rougher and irregular. So if you remember from the lab lecture, there is a term that is commonly used, which is classed. So when we talk about sedimentary rocks, we are not referring to large class as phenocrysts. We call them class, and this is connected to the fact that we understand that this rock is a sedimentary rock. So how can we tell that this is a sedimentary rock? It's because of the heterogeneity in composition of the class, for example, and the fact that they have relatively irregular shapes. In this particular case, I can definitely see here a cluster that is well-rounded. And if you remember from the lecture, we have discussed that the level of rounding of class is quite important, because it does give you an indication of the level of transport that this rock has witnessed. So usually rocks that have had a significant amount of transport and reworking, they will tend to be relatively well-rounded. So we could essentially look at angularity as also a property for the classification of the nomenclature of these rocks, but we will discuss this later. In this case, we have to focus on a description of what we see. And here I definitely see large classes, so I would express the dimensions of these, which, you know, based on the classification that we reviewed, they exceed clearly the 2 millimeters. So we're not talking about a sandstone in this case, talking about a very coarse, gravelly rock assemblage. So these gravels are actually dominating in this rock, and therefore you can think of this rock as a rock that has at least more than 30% of class that are exceeding the 2 millimeter size. So gravel in this rock dominates. So I think this initial observation are sufficient, really. We can recognize a rock that is very coarse. It does have very large clasts, as well as interstitially we can recognize a finer grain matrix, and this matrix is characterized by grains of variable composition. So the impression is that we have darker grains, which could be biotite or other ferromagnesium silicates, as well as a more brownish cement that could be either silica or carbonates. So to work on the matrix of this rock, we have to use acid so that we can understand the composition of the cement. So of course, if it does fizz, you can recognize some of the mineralogy. But as I was expecting, in this case, there is no fizzing at all. So this is a highly siliceous rock that essentially underwent diagenesis and consolidated in an environment that is usually devoid of carbonates. And because of that, you tend to have a silicic composition of the cements. So it's mostly quartz or chert that will sort of compose the interstitial cement that glues together these different clasts. So let's move to another example. So I'll put this very coarse example here. And of course, since we have this exercise of looking at grain sizes, what we are trying to do here is to group rocks that have firstly coarse assemblages, and in this case I have another one that definitely has a much coarser appearance if compared to others, and is very much similar to what we just discussed, although there are some differences, and we'll do a comparison later. But definitely this is a gravelly rock for sure, and it does have more than 30% of large cluster exceeding the 12 millimeters. So it's a rock that can go in that group as well. Let's see if I have other examples here. Certainly we have a good example here of another rock that has quite a bit of fragments exceeding the 2 millimeters. Of course, the matrix in this case is very much different from what we saw earlier. So we would have to test if there is any carbonate, and also sort of discuss the composition of this class to make any distinction between these and these other specimens here that look more siliceous. But yeah, they still might have a similar composition. In terms of grain size, however, I can say that these are slightly smaller. So the grain size here is a little bit smaller, and there is a little bit more heterogeneity in terms of grain size. So we have class that are on the order of less than half a centimeter, to class that exceed the centimeter, to very tiny class that are on the order of 2 millimeters. So things that could start to become classified as sandy, really. Although the majority of the cement appears to be relatively fine grain. But because of this, I would place still the rock in this group because of the large class that are present. But in this case, it seems that the matrix is more abundant, really. Any other examples? We have this other example that is quite interesting. It's still a rock that we can define as sedimentary because of the abundance of angular class. But yeah, this is a key distinction, really, as well. We can see that most of the class here are very angular, and there is also a more so essentially the rock is represented by two end members. So we have an end member that is this class, and these have a unique composition, and then we have another end member here, which is this fine grain crystalline cement, which is pinkish in color, and so we have to test if this is carbonate or not. Although we have to be careful because I can see cavities in this rock, which would indicate the possibility of a reduction of volume that is often linked to processes such as dolomitization. So even if it doesn't fizz, I would interpret this potentially as a carbonate. But yeah, for the sake of grouping this rock, we can still place it in this set of rocks because of the large class that are included in it, and so mostly very large class are part of this specimen, and so I think this is in agreement with the above 2 millimeters classification we are using for the grain size. Okay, so everything over the 2 mils is usually a gravel, and here we are really talking about cobbles. so things that are even larger in size, so sometimes exceeding the centimeter really. Let's see if I have other. So we have this example here, although this is more peculiar. I would definitely not group these with these others, because this has certainly fragments of material that is, however, peculiar, because it is actually of biogenic origin, and so because of that it is better to use usually a classification and a grouping scheme that essentially is dedicated to biogenic rocks. So let's put it here, but we certainly see that the principle is very similar. We have large fragments that have been accumulated and cemented by a small, relatively fine-grained matrix. So this is the same, but you have different sections of these organisms that usually are discoidal in shape, and they might actually appear, as in this case, ice-oriented, and therefore you can see essentially sections through these elongated stems. Okay, other grain sizes that are relatively coarse would be still these. So this rock assemblage is also of biogenic origin, and so it does have relatively large fragments, which we will discuss later, which are these dark colored fragments, so black, essentially remnants of organisms, and again a matrix that is, however, a little bit coarser if compared to some of the previous specimens, but yes, still a biogenic origin. So we have a group of biogenic rocks really entering into play in this grouping. And between biogenics, I think I would potentially add also these, although these are very fine grained, so they cannot really sit in this group, because in this case we are classifying rocks based mostly on grain size. So these are still pretty coarse. They have very large fragments. So let's keep them here, actually. But yeah, keep in mind that those are biogenic as well. So I think I've exhausted the very coarse specimens. We can try to look at things that would be more halfway between these examples that we've just discussed. So this very fine grain biogenic material, coarse grain biogenic, and non-biogenic that is very coarse grain as well. So what's in the middle? I think this would be easily sit in the middle. So we have a specimen here that has no evidence of really large class, so no cobbles in here, but yeah, still some grains are actually larger than the 2 millimeters threshold. So in this particular case, we would be sort of in the middle really, and we could talk about rocks that have, for the majority, a very fine grained matrix cementing this gravelly material. So you can have often layers that are more gravelly, and then you have more finer grain assemblages in this type of stratified rocks. So certainly one of the difference with finer grained rocks is that you start to see some stratification. So for example, in here I can clearly see a layer that has a distinct composition from the other grains that compose the rock and represent the framework of this sedimentary rock. One other thing I can certainly see is that we have an heterogeneity in the class composition, so we can definitely see different colors that would be quite helpful in identifying the mineralogy of this rock, which we will do later. But you can see, I can clearly see the grains with my naked eye, so I don't need any eye and lens to be able to actually recognize the mineralogy. So that's kind of an analogy with some of the intrusive rocks that we discussed earlier in the course. So you can see here clearly the grains. And that's good enough for me to put this rock really in the middle here between the very coarse and very fine grain. Other examples could be this one here. So we have a very similar rock, although we are starting to see that it becomes difficult to see the grains. But I can still see a sort of a sandy appearance. And so sandstones often have this characteristic, very gritty texture. Another way really to identify a rock that is on that 2 millimeter threshold really is really to feel with the touch of your finger the surface of the rock. If it feels very gritty, a little bit like the pumices, then you are certainly feeling the grittiness by sort of picking up the coarser aspect or coarser fraction. So you do have that mostly this rock has small grains that I can still see and I can still feel really well with my fingers. So definitely it's a rock that has an intermediate grain size if compared to others. So if I take this rock here, this one is very smooth. I don't feel really anything in terms of grains, so it's not really gritty. And because of that, I'm pretty sure that this rock is very fine grain. And also, it does display conchoidal fracturing, which is also interesting. Let's see if I have other examples that could be sort of intermediate. In this case, we have a rock that is composed of multiple layers. Some layers definitely have coarser mineralogy, but others that are the more reddish one are definitely fine, extremely fine grain. So we are really approaching this side, so the grain size is getting really smaller and smaller, but still I can see definitely some grains in this rock, especially in the more in the layers that are gray to gray metallic in color. So these you should remember could be actually some of the oxides we were mentioning earlier in the first lab when we were discussing oxides and sulfides. So that's an important argument. So we have some evidence of coarser mineralogy that would still put this rock a notch upward if compared to these other. These other rocks start to be very difficult because we do not really see any grains. But I have still my fingers that helps me with the classification. I can feel that they are actually a bit gritty, so they're not as smooth as this specimen here. So definitely with the feeling of my thumbnail, I can definitely see that this rock is coarser in grain size, just based on the feeling I have. So this is a bit of a challenge with this online course, but yeah, if you have the opportunity to go in the field in the future, and you will sort of have a specimen in your hand of a sedimentary rock, and you feel that is relatively gritty to the touch, but also you do not see really any grains. Well, that's a good way of establishing that the rock is relatively fine grain, but also is not as fine grain as other varieties that are much smoother. So the feeling is something that you can sort of remember that it will help you in the future when you have to deal with rocks of this type. So you will feel this much more smooth, and engineers usually know this quite a bit because of the coal mining. So this is coal, and so that's very helpful sort of as a criteria for the classification of sedimentary rocks, the degree of smoothness. What about this greenish rock here? It does smell quite a bit. So another important criteria we will see is really understanding the amount of mud that exists in a rock versus carbonates. But that's something that is more sort of with respect to the composition of the rock. But yeah, it's important to know that. And again, for the grain size, you have to rely on your feeling. But in this case, I can definitely see some grains, although they are very much finer in size if compared to the red materials we had here, and also they are much finer than some of the layers in here. So we could certainly put, I think, this specimen in this domain here, but yeah, it's still sedimentary rock. I can see the stratification really well, although it's a bit more complex. So we have some cross beds in this rock, but yeah, certainly it's a rock that is relatively fine grain, but not as fine as coal. And then we have this other rock here. I think this one has really the same type of grittiness, and I don't see very much any grain really in here, so it's even finer than this. So I think it would sit really close to this other specimen. We have here another example, and this one is very smooth. I can see some curvature here, so it's very conchoidal in its fracturing. So this is definitely a rock that is extremely fine grain because of that. And so definitely it could sit really in this domain, and the same is true for this one. It's very smooth, and you can see the curvature in the fracturing. And yeah, it's kind of interesting to see also some of the layering. It's very complicated layering, and it looks as some layering is rather convoluted. And so this is a sedimentary rock, but likely has a more complex history. But it's very fine grain, so it's almost sharp here, which suggests that there is quite a bit of silica in this rock. So we can put it very close to this one because they're very similar in some way. The conchoidal fracturing, I would say, and the fact that the rocks are both microcrystalline. This rock is very similar too. It's very microcrystalline, but it does seem to have a very much different composition. It's actually quite soft. I can easily scratch the rock with a steel file, so it's very easy for me to sort of test the hardness of this specimen. And beside that, this is more a compositional issue. and it's rather we are concerned more with the grain size. And yeah, definitely I can say that this grain size is quite fine grain, so I would put it right here because I don't see any grains, and it's a little bit grittier than these other specimens that we just sort of went through. Okay, other specimens are in here. This one is very similar again to this. It's actually the same rock likely, so I'm not going to bother working too much on that. This one is very gritty. So again, lots of strata. I can see definitely stratification in here. I can see some of the grains with the naked eye, although they're very tiny. I can see definitely the grains in here as well. The rock is dotted, so I can see darker domains that are represented by small crystals, and also I think the rock is really feeling gritty to the touch, so it's somewhat closer to this specimen, so I would put it actually here in terms of level of grittiness, and as a consequence of that I think this rock has coarser grains, and we are likely on that 2 millimeter mark that is really separating out the sandstones from other varieties, but we are going to discuss the classification later. Firstly, we order the rocks, and then we will talk about the compositions a bit more. This one is quite smooth, I would say, very smooth, and I can see some stratification here, although it's very complicated. It's also really smelly, so I think I would put it here with this other rock. They're very similar, I think, in terms of composition and also grain size. We're left with only 2 specimens. This one is very, you can see it's quite well crystallized, I would say. So I think this rock could be even a metamorphic rock, really. But I think I have this in the collection here because what is termed as the protolite or protolith is a precursor rock before the metamorphism. And sometimes if the metamorphic grade is not too high, you tend to have situations in which you can preserve some of the sedimentary structures that were existing. And in this particular case, you can see this pattern that show essentially a set of crests of ripples. And so we have essentially ripple marks that indicate that this was either a lagoonal or essentially a seashore environment. So it could have been a foreshore, for example, where you have a lot of waves moving back and forth and sort of reworking this sediment, which would fit also with the composition of this rock. My interpretation is that this rock was originally likely dominated by quartz, which would agree with the level of reworking of these pre-existing sediments. It feels really gritty, so likely in origin it could have been interpreted as composed of grains that were on the order of 2 millimeters or more, and so because I can feel the grit, it's quite gritty, and yes, it's almost monomineralic, although there are some minerals that I can recognize here along this fracture, but this could be secondary minerals as well, so I have to be a bit careful with that in interpreting some of this mineralogy. But yeah, it's possible that some of these were also primary. I think in this case the interpretation is challenging. I can see some original stratification in here. But yeah, since we are classifying this rock based on grain size for the moment, I would state that this rock is still fairly coarse, so I would put it with this group really. And this last specimen is very smooth again. I can see definitely evidence of very fine layers, so these are on the order of a few millimeters, so the stratification of this rock is really an indication that you had a lot of variations during the deposition of this sediment, and the sediment was extremely fine grain, and likely it contained quite a bit of organic matter because of the color. It's very dark, but yeah, the grain size is very, very fine. I can still feel a little bit of grit, so I would probably place the rock in this group here. So pretty much all these rocks are very close to each other.